Use the second derivatives test to determine the nature of the surface at its critical points. Our surface is f of xy is 12xy minus x cubed minus y cubed. So first we have to find the critical points. These occur when f sub x is equal to 0 and f sub y is equal to 0. So let's do that first. If f sub x is equal to 12y minus 3x squared minus 0, and f sub y is equal to 12x minus 0 minus 3y squared. So we have the system 12y minus 3x squared equals 0, and 12x minus 3y squared is equal to 0. Let's take the first equation and solve it for y, and then substitute that into the second equation. So 12y is equal to 3x squared, first equation, divide by 12, y is equal to x squared over 4. And then we will plug that into the second equation. So that'll give us 12x minus 3 times y squared is x to the 4th over 16 is equal to 0. So we can factor out an x, and we have 12 minus 3x cubed over 16 is equal to 0. So either x is equal to 0, or the quantity in the parentheses is 0. So 12 is equal to 3x cubed over 16, which means x cubed is 12 times 16 divided by 3. 12 divided by 3 is 4. 4 times 16 is 64. And if x cubed equals 64, that gives us x is equal to 4. So the critical points are, if x is equal to 0, so either x is 0 or 4. If x is 0, y is also 0. And if x is 4, then y is 16 over 4, which is also 4. So we have two critical points, 0, 0, and 4, 4. So now we calculate the discriminant at those 2 points, which involves the second derivatives. And we have f sub xx. Here's f sub x right here. So f sub xx is negative 6x. F sub yy is negative 6y. And f sub xy is 12. So our discriminant is 36xy minus 144. At 0, 0, the discriminant is negative. It's negative 144, which is negative, and that means that we have a saddle point. It means that we have a surface that in one direction is bending one way, and in the other direction is bending the other way. So like concave up in one direction, concave down in the other, making a saddle. And at 4, 4, our discriminant is 36 times 16 minus 144, and that's positive. So we have a local extreme, and then to determine whether it is a min or a max, we look at f sub xx or f sub yy at the point 4, 4, and f sub xx was negative 6x. So this number is negative 24. F sub yy was negative 6y. That would give us the same exact number, and that's negative. So that means that in both directions our function is concave down. And when you have a concave down function in one variable at a critical point, then that means that you have a local max. So we have a local max at 4, 4. So a saddle point at 0, 0, and a local max at 4, 4.